Hello YouTube, so today we're gonna do a video on this robot right here. You may have seen in a couple of my previous videos that I made this robot. This is a small robot, unlike my two larger robots. I don't have the walking one, but there's the one on wheels right now. I put new motors controllers on it, if you see there. But we're gonna mainly focus on this robot because this robot is functional now. I wouldn't really say complete, but it does work. So you could see this is based off of like one of those robot kits that you can buy for like $10, and then this is a electrical blanking plate, a piece of PVC. It's a PVC piece of plastic, and what I did is I zip tied this PVC plastic to the frame of this robot to extend the place where I can mount electronics. And I did that because of the electronics which you see here. This is a motor controller. It's an L298 motor controller, which controls the two motors of the robot. They're very small motors, so you can get away with using a smaller motor controller. This motor controller can control the two motors or can control one stepper motor, so we're controlling two normal DC motors with it. You can see it has a data cable which controls the motors. This is each of these pins controls whether one of these motors go forwards or backwards. So if one of these pins is high, this one goes forward. If the other one's high, it goes backwards. If this one's high, it goes forwards. If the last one's high, it goes backwards. So you have 4 pins. If one of them's high, it goes backwards, this way, this way. So that allows us to control all these motors with the Arduino right here. And that's how I programmed it, is so it would normally go forward, and if it's within 5 centimeters of an object, it'll go backwards. How it can determine whether it's 5 centimeters close to an object is using this ultrasonic sensor. And basically what it does is it sends out an ultrasonic pulse, it bounces off the object, and then it measures the time it takes for the sound to come back to the sensor, and then using the speed of sound it computes exactly how far away the object is in centimeters. And then if the object is less than 5 centimeters, well, equal to or less than 5 centimeters, then that tells the Arduino to tell the motor controller to go backwards. And it goes backwards for a fraction of a second, and then it goes forwards again. Well, it doesn't just go backwards, it goes backwards and then it turns and then it goes off in a new direction. So you could see using this method, it should be able to avoid all obstacles. I'm going to do a demonstration of it soon, just so you could see it. Also, here we have the Arduino. It's an Arduino Nano, and I made a circuit board for it using header pins and a proto board. So basically all of these pins correlate to one of these header pins. And also I have a positive and negative power rail. So you can see all the black wires go to the negative end, all the red wires go to the positive end. Also, there's a battery here. It's supposed to be a 9-volt. Well, it holds 8 AA batteries. I'm only using it with 7. These are rechargeable batteries, so if I was using 8 AA rechargeable batteries, it would give me 9 volts. But how I'm using it right here, it gives 7.8 volts. And that's more than enough. These motors normally take about 6 volts, so 7.8 volts. So it's normal power for what this would consume. Also, for the ultrasonic sensor, the trigger and echo pins are connected together, just because that's how it works. If you may recall, it pings a signal out, waits for it to come back, and it computes the amount of time it takes for it to come back. So while it's doing that, it's never using both pins at the same time. So it can have trigger and echo, and they never interfere with each other. So that's why you would normally use only 3 pins, 2 for power, 1 for data. And that's how it is on the stock Arduino programs for ping. So if you're going to use it like that, you have to wire the 2 pins together. So let's just look at it right here. You can see it powers up. You should go forward. So you see it works. It's hard to capture on camera. So it goes forward, it goes backwards. You see, here's the problem it has right here, is it has to be like close to an object. And sometimes it gets stuck too. So it's not exactly a finished idea. You can see it just gets stuck here. I don't know why it's going in circles. There we go. No. Alright, so I don't really know what it's doing. So yeah, it does work, but it is still kind of rough in how it selectively works. It just died right there. So maybe the batteries are low. That's all I can think. This thing does take a lot of power, just because it's driving motor controllers and the motors and other stuff. Yeah, so I'm gonna assume that the batteries must be low. Either that or just not connected well. Probably not connected well, actually. Oh yeah, because the power pins, they go all the way here, so it's kind of exposed. That might be why it doesn't work exactly good. Or it could be this. This is, you see, this alligator clip has to connect. And I'm not sure if it does. So why is this dead? So it'd be funny if it just started, like, caught on fire right here. That'd be funny. But no, it looks dead. Don't know why. So I'm gonna be working on this more. You did see in the clip it did something. So I'm gonna be working on this more. Maybe I'll make another video later. Just from what I see right now, either the battery's dead, it's not connected, or something else. So I'm going to be working on this more.